Good morning, students. This is Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are seeing the subject called Robot Dynamics and Control. The subject code RA3601 under the regulation of 2021 for the 6th semester for the third year students. So far, we have completed 2 lecture videos in this Unit 4. Today, we are going to see the upcoming topics. Left of topics in Unit 4 also we will discuss today. We will see one by one. So in this, the first thing, the syllabus which I highlighted over there. In this, the main topics what we are going to discuss here, we have a glimpse in this slide. That is MI/MO systems and the industrial robot control. That is time varying systems, multi-input, multi-output systems, manipulator control problems, practical considerations, industrial robot controllers, and industrial applications. Review of time varying systems. A system is called time varying if its parameters change with time. General state equation here we can write like this: x dot t equal to at xt plus bt ut. At is nothing but a time varying system matrix. Bt is equal to input matrix. Xt is state vector. Ut is control input. Examples in robotics: robot carrying different payloads, battery powered robots, flexible manipulators, variable speed actuators. That is, the example is industrial robot lifting a 2 kg object and later a 20 kg object experience significant changes. So here we can see MI/MO systems, that is multi-input, multi-output systems. First thing we can see single input, single output. Here we can have a glimpse of this picture representation. The left hand side we can see SISO system. Motor is there. Again, it is connected with a gear system to get the output. Single motor conveyor belt is there. Now this is a robotic function. How it is function means multi-input, multi-output. So various input is given. Here we can see the top we have the U1, U2, U3. Various inputs are given, and correspondingly various output also we are simultaneously we are getting. That is Y1, Y2, Y3. Multivariable, coupled, controlled, multi-joint industrial robotic arm we are getting over. That is U1, U2, U3 followed by Y1, Y2, Y3. MI/MO systems, that is multi-input, multi-output. MI/MO systems contain multiple output controls and multiple outputs operating simultaneously. Characteristics: we are having multiple actuators, multiple sensors, strong coupling among variables, simultaneous control of several output. Why this MI/MO is important? Most real world engineering systems are MI/MO. Robot manipulators, aircraft, chemical plants, autonomous vehicles. Advantages: improved performance, better resource utilization, simultaneous control of multiple variables, then higher efficiency. The challenges: complex mathematical modeling, interaction between input and output, increased computational requirements. State space representation. MI/MO systems are usually representation using state space equations. State equation is defined by x dot equal to ax plus bu. Output equation is y is represented as cx plus du. X is nothing but state vector, u is nothing but input vector, y is output vector, a is input matrix, b is input matrix, c is output matrix, d is feed forward matrix. For a 4-joint robot, we can write input vector as U equal to tau 1 plus tau 2 plus tau 3 and tau 4. It is transverse vector, transverse matrix. It is written like this, and output vector also y equal to q1 plus comma q2 q3 q4. Significance: the state space model provides a compact representation for designing model controllers. Robot manipulator as a MIMO system. Why manipulator MIMO system? A robot manipulator consists of several joints, each having independent actuator input, position output, velocity output, acceleration output. Example: 4 degrees of freedom manipulator. Here it is given as a various input: tau 1, tau 2, tau 3 and tau 4. Output is q1, q2, q3, q4. Coupling effect: movement of one joint influences the dynamics of other joint. Implications: the controller must coordinate all joints simultaneously. Real example: industrial welding robots typically have 6 degrees of freedom, resulting in 6 inputs and 6 outputs. Here we can see the video is highlighted over there. A welding on frame with having a 6 degrees of freedom, it is mentioned over here. Manipulator dynamic equation. Robot motion is governed by non-linear dynamics. Dynamic model: mq q double dot plus q c q dot plus g of q equal to tau. Components: inertia matrix m of q, already we defined in the previous video also. The notation already we might have we already discussed in the previous video also. Students, please go through the previous video of this same unit. That is Cholerace and centrifugal matrix, gravity vector, that is torque vector tau, control input generated by the actuators. Then challenges in manipulator control, that is practical difficulties. What are the practical difficulties? Means that is payload, that is payload variations. Different load alter robot dynamics. So human being can carry different type of loads whenever it is needed. We can apply more effort to lift the load. But robot means you have to alter the robot dynamics in order to carry the different kind of load that is handling. Friction means that is introducing a non-linear behavior. External disturbances, unaccepted forces affect motion. Unexpected forces that will affect the motion. Joint coupling: one joint influences other. Sensor noise reduces measurement accuracy. Parameter uncertainty: exact robot parameters may be unknown. Consequence: what are the various consequences? Means we can see it is a reduced accuracy, oscillations, instability, increased energy consumption. Importance of sensor. So main thing is sensor in the robotics. Sensor is very important. Sensor provide feedback required for closed loop system. Already in the previous video we have seen what is a closed loop system. For the sensor will take the feedback to the input control to get the desired output. Position sensor measure joint angles. Velocity sensor measure rotational speed. Torque sensor measure applied force. Vision system provide object recognition and localization. Proximity sensor detect nearby objects. IMU sensor measure acceleration and orientation. Here various sensors is mentioned over here for your understanding purpose. Kindly go through these sensors: temperature sensor, ultrasonic sensor, vibration sensor, tilt sensor, level sensor, touch sensor, gyroscopic module sensor, soil moisture sensor. Okay, the various sensors it is mentioned over here, and in the robot where it is placed also here we have highlighted in this picture representation. Industrial robot controllers, that is PID controller, most widely used industrial control, that is control law: ut equal to kpe plus ka integral e dt plus kd e de by dt. Advantages: simple implementation, low cost, reliable operation, poor handling of non-linearities. Computer torque control uses robot dynamics directly. Features: gravity compensation, Corliss compensation, high precision, excellent rigidity tracking, that is advantageous one. Adaptive control, automatically adjust to controller parameters. So adaptive means automatically it should be adjustable, otherwise it won't get function. That is application variable payload. That is told in the adaptive control. Wherever it will automatically change to handle various type of loads over there. Changing operating conditions, improved robustness. Here we can see industrial robot control architecture. We can see over here external devices is mentioned as input output module, that is a real time, non-linear time, non-real time. Control unit is mentioned over there. Trajectory executive servo try control module and a command interpreter and trajectory planning. Various control unit is mentioned over here. This architecture illustrates how commands are processed and executed in an industrial robot control system used for offline and online programming of robot tasks. That is non-linear, non-real-time control executes robot programming, interpret, control, and generate motion trajectories. That is a non-real one. Here, real-time control processes sensor data, performance servo control to ensure accurate motion. Here, the sensor will be main purpose, the real-time controller, to get the accurate motion. Servo drives convert control signals to motor torque and motion commands. Industrial robot IR executes required tasks such as welding, assembly, or material. This I have already given in the introduction part. What is the various industrial purpose robots, what it is doing over there. Feedback system continuously provide position and velocity information to the controller for error correction. External devices PLC, programmable logical controller unit, vision system, and other sensors interact with the robot through the input output module. So various benefits we can see over here, MIMO based robot control. Technical benefits, simultaneous control of multiple joints, improved tracking performance, better disturbance rejection, high accuracy. Benefits, increased productivity, reduced manufacturing cost, improved product quality, enhanced workplace safety. Summary, industrial robots are naturally MIMO systems. Time-varying behavior must be considered in practical application. Robot dynamics are non-linear and coupled. Control system address positioning, tracking, and stability. Sensor provide essential feedback information. PID, computer torque, adaptive controllers dominate industrial practice. MIMO control is fundamental for modern industrial automation. So these are the various references which I used for preparing this content. Kindly go through these references for your understanding purpose. So thank you for your kind attention. Please subscribe this channel and share this video to your friends. So we will meet in the upcoming video for the next topic in the unit 4. Thank you, students.